Is that messed up?
You told me that there was a typo or something.
Yep. Okay, thank you. Okay, well, here's the first example I want you to try in your notes. This angle here is 28 degrees. This up here is 30 feet. This down here is 70 feet. I am going to label this ABC, so this is little a, little b, little c. Find angles A and B and side C. I'll give you a couple minutes to set that up, see what you can come up with. So our first step here, first thing we've got to check for is, remember, do we have a side and its opposite angle? Do we have that here? No, so what does that mean? We can't use the law of sines. We have to go to law of cosines. And law of cosines, since our angle is angle C, I labeled it that way on purpose. So the missing opposite side is side C. C squared equals A squared, so that's going to be 30 squared, plus B squared, so that's going to be 70 squared, minus 2 times A, which is 30, times B, which is 70, times the cosine of angle C, which is 28 degrees. So I can punch this into my calculator all at once. Remember, we did a square root here to cancel out the squared. So C is equal to the square root of all this at once. 30 squared plus 70 squared minus 2 times 30 times 70 times the cosine of 28. And remember, some of your calculators you have to close the parentheses twice. I didn't have to close them twice, but I did anyway. It didn't affect it any. 45.73 is C. So C here is 45.73 feet. So I've got that piece. Now I do have a side in its opposite angle. I have the 45.73 feet over the sine of 28 degrees. Now I can find either one of the other angles using the law of sines, which is what I started setting up right here. Which one do I want to use first, the 30-foot side or the 70-foot side? 30. Always use the shorter side. Because remember that sine, when we do the inverse sine, it does not tell us whether the angle is obtuse or acute. And the larger angle is the only one that can be obtuse, will always be opposite the larger side. So we're going to put 30 over the sine of angle A here. We're going to cross multiply. Sine of 28 times 30. Sine of 28 times 30. Oops, that ain't going to work. I got to put close parentheses there. Sine of 28, close my parentheses, times 30 divided by 45.73. Gives us 0.3079. Yes, sir. So that comes out to be 0.3080 actually. That's the sine of the angle, so A is the inverse sine. .3080. So on my calculator, just second sine, second answer. 17.94 degrees. So that is angle A here. I add that to my 28, that's 45.94. Subtract that from 180. 34.06 degrees, or 134.06 degrees is angle B. So now there's a good thing here that I did use this side first, because when I did the inverse sine here, I would have got something like 46 or 45.94 degrees. Well, how would I have known that that needed to be obtuse? I mean, the triangle looks like it might be obtuse, but you couldn't tell for sure. So always use the smaller of the two sides first to get the smaller angle. And of course, C I'm just going to fill in. We found that already, 45.73 feet. Any questions on that? A here was from the law of sines. I had that 45.73 over the sine of 28 right here. And then 30 over the sine of A. Cross multiplied and divided to get 0.308. Now the sine of A is 0.308, so I have to do the inverse sine. Get that A is that 17.94. In this triangle, I give them 31 degrees here. I give them a side of 19 inches and 21 inches here. And I tell you that this angle, that's not going to work. Let me do this. I'm going to give you this one up here. Let me tell you that this is 36 inches. And I'm going to tell you this angle here is obtuse. So I'm going to label this however I want to. So this will be little a, little b, little c. Do I have a side in its opposite angle? Say yes. Yeah, I do. 21 inches over the sine of 31 degrees, its opposite angle. Now the only other piece of information I have is the 36-inch side. What's its opposite angle? Sine A. Good. So we're going to cross multiply and divide here. So sine of 31, close that parentheses, times 36 divided by 21. I get 0.8829. Now that is the sine of angle A. So A is the inverse sine of 0.8829, which is going to be second sine, second answer. It's going to try to tell us that's 61.99, 62 degrees. But can A be 62 degrees? No, because I said it was obtuse. If it's obtuse, that means what it really is the supplement, 180 minus 62, which is 118 degrees. That's 118 degrees. That makes this one 31 degrees. Yeah, we have to take 180. We know that's obtuse. We have to take 180 minus that angle. Looking familiar? Now a little bit of review of our inclined planes. Let's say we have a 35 degree, or vectors I should say, 35 degree inclined plane. And I've got a 350 pound box. So what I'm going to do is I'm going to draw it like that. Because gravity, of course, pulls straight down, right? Well, we're going to break this force into two forces. This one and this one. This is called the perpendicular force. That upside down T means perpendicular. This one's called the parallel force. Those two parallel lines means parallel. So what we're doing is we're taking this 350 pounds and we're breaking it down into pieces that look like that. Now that 35 degree angle is right here. What angles do I know here? Well, what's this angle here have to be? 90 minus 35, 65 degrees. What's this angle have to be? Parallel, perpendicular, right? Because if one's parallel and one's perpendicular, then they have to make a right angle, right? So, of course, that would make this 35 up here, or not 35. This should be 55, not 65. 55 degrees, not 65 degrees. 90 minus 35 would be 55 degrees. And I know that this is 350 pounds here. So I can find this amount here That would be the adjacent side, right? So that'd be my 350 pounds times the cosine of 55 degrees. £200.75. And so that's the force parallel. The force perpendicular, this one here, is going to be the sine. That's the opposite side. So that's going to be 350 pounds times the sine of 55 degrees. $286.70 pounds. Why is this important? Well, this is the force that's wanting to make that slide down here, right? There's something called the coefficient of friction. The coefficient of friction is the amount of friction force that holds that box in place. And that friction force is related to this perpendicular force. Let's say the coefficient of friction is 0.3. What that means is friction is going to equal 0.3 times that perpendicular force. So that's going to be 0.3 times 286.70. So my 286.70 times 0.3 is 86 pounds. So what that means is friction will hold 86 pounds up here. How much is pulling this way though? 200.75 pounds. That means this box is going to slide down the ramp. Does that make sense? Okay. With that, I have a quiz for you guys to take. What's going to happen tomorrow in class? Number one is turn in quiz. Now there is then number two, there is a unit test for unit 4. And there's maybe one or two topics that we didn't really totally get to, but we've hit on them. I would have covered them more if we had another week of class. So the second thing that's going to happen tomorrow is there's going to be a unit/final test. It is an optional test. Doing the test will help your grade. You can't hurt it. So Mark's extra credit thing? He has an extra credit thing he's giving you?
No, the way he does extra credit. So if you do it, he'll give you the points, but whatever you get wrong, he'll take off your score.
Oh, really?
Yeah.
No, it won't hurt you. So if you do the extra credit and you screw it up, no, I won't do that to you. I won't penalize you for doing extra credit. But I mean, it's stuff that you should be able to do. And in class tomorrow, I will let you guys work on it as a group. And whatever you get done for points. We'll go from there. So I will give you this quiz.